if your grade for the midterm is below 60, you fail the midterm. Then you need to correct all the errors. We submit your solutions by today. And we made an announcement Tuesday, so it's due today.
Did we turn the midterm correction by?
Yeah, I'm just gonna put it. Yeah, I'll give this.
They're just for someone to be annoyed by it. It's just like, oh
Alright, so my name is Hector.
I'm Pilar.
I'm a D.
And we did the autonomous car that follows the track.
So our goal was to make the robot follow a straight line or a track. We use sensors to analyze analog signals to control the rest of the screen. We use an ultrasonic to avoid knocking. The procedure, we constructed the Arduino. We color coordinated the wires. We made sure that we have enough power for all of our sensors. We gotta calibrate the polarity of the motors because if they'll both be one, they'll turn opposite directions. So we gotta fix that. We gotta make sure the sensors are working with like online libraries that give like the demo. We had to make sure our track that we use to test our car had like the correct color balance. Some of the challenges was pretty much the distribution of the weight. Sometimes it'll lean more to one side than the other. Sometimes the batteries didn't work, so our max speed will be 255 and we'll just get like a slow speed. We gotta make sure the sensors were reading accuracy. We gotta interpret the ADC values from the ADC chip on the Arduino. We gotta find out what was our max, what was our min, what did white read, what did black read. And we did have a problem with the wheel where every time the wheel would turn, it would grind against one of the bolts, one of the nuts on the little car.
So this is a picture of our first prototype that we did. The only thing that we made it do was track the black line, avoid the white space, and make it stop on the red line. And if you will, can you show it up, just the robot? So what we did, we moved the sensors on the back. So we had the sensors in the front, had a little color sensor on the left side. So we did, we moved it to the front, on the back, sorry. We found out the wheel was causing most of the issue, making it turn left or right. We also moved the sensor on the side, and also we attached the sonar sensor to detect objects.
So this is what our code looks like. So basically it starts off with the color sensor and it uses the clear function of the color sensor since we're using an all white track. So if the color because the color sensor, when it reads white, it reads at a value of like 21 compared to the red, the blue, and the green, which are really low but really close together. So we found it easier to use the clear color reading, which when it read, it was like around 21. So we set it, if the color sensor reads greater than 15, then it's gonna enter these if statements, which read the black line. So if both the line sensors are above the threshold, which the threshold is set to what the line sensors read on the black line, then it'll go forward. And if one of them reads less or the other one reads greater, then it'll go right, and so on left. And then if the color sensor reads anything other than clear, so like black or red, it'll stop for 3 seconds and then go forward. So to implement the distance, the ultrasonic sensor, we set the distance to, we set it to check if the distance was, I think, centimeters, right? 10 centimeters. And it's gonna call the function semicircle, which we set to be, it's gonna make the robot turn left for about 2 seconds and then turn right so that it'll get back on track. So it'll like go around an object. So to test it, we had to first test the line sensor. And when I previously did it, I had put them on the robot with paper clips, which like really didn't let them be stable. So when I redid it, I used like a thick popsicle stick and I taped the sensors together so that they would both read like almost the exact same value, because previously they were reading off like, they were reading at about like 100 integer value difference. And then the color sensor I noticed was, since the color sensor has a bright LED on it, it was interfering with the line sensor. So I also put that on a popsicle stick and I set it lower so that it could block some of the light. And I changed where the battery pack is because it originally was printed. When you built the kit, it originally laid here. So when we were testing, we killed our batteries a lot. So it was really hard to like replace batteries. Like I had to unscrew the whole thing multiple times. So I put it on top of the part, which helped with the weight distribution as well. And then the ultrasonic sensor, I set it on the right side and I taped it to one of the bolts, so to keep it like more stable.
So here's a little brief, I guess progress is the testing. So this one we made track the black line, we're gonna go around. So the next line, we made a stop at the red light, red stripe. And then for this case, we made it avoid the obstacle, which is that little Gatorade bottle.
Oh wow.
That's it.
Demo?
Yeah.
Yeah.
Wait, we can go first?
Where is it?
There's a delay for 10 seconds, so give it a little time.
Let's put it down. Let's put it down. There you go.
Can I change the threshold?
Might be the lighting. Yeah.
Let me program it. Off,
Do you have a flashlight in your phone?
Because as
Try
you
out
can see,
the-
different groups use different types of sensors for object detection. Some of you use the IR infrared sensor. This group is using the ultrasound sensor. So have you thought about the difference? How do you make a choice if you have two sensors available for object detection?
Try to put it on the. See if it light.
So IR sensor is more sensitive to what? Light environment. Ultrasound relies on the electric sound wave, so it's more resistant to the
Thank you.
lighting.
Yeah. Thanks, Neda. If you guys need more lights for the line sensor,
No?
I did pass like a flashlight.
You just need more light.
I don't know.
Keep it on.
You have chance to test on this?
We tried it on our own track.
Oh, okay. So you haven't tried this on this track yet? Okay.
I think our board was wider
Some
too.
student commented it may not be thick enough.
Yeah.
Probably.
So let's see, alright?
That's a 10-second delay. Start over there. Yeah.
What's wrong?
It's running, but nothing stop.
It's like it's not reading anything.
How thick is the track in your camera? Is it much thicker?
Yeah, it's like a styrofoam plate. Like a
Okay.
plastic.
So maybe we can make this thicker, because thicker make the tracking easier, right?
Yeah.
It's your. Can you
How
hold
about
this? Can you hold this?
Okay,
never mind.
One second. Yeah. So people will not upgrade.
Do you have them?
It's in my car. What do you need? Can I bring my own strap? Or does it have to work on this Yeah.
Right, class? Okay, so let's give our applause to this group. The ultrasound, so tracking I guess the track in the line is not big enough. Plus, their robot, the speed is set too high. I think when the bot is moving slowly or the track is thicker, it's more likely to stay on track, right? Okay. So one question for you guys to think is, if you have those options for object detection, ultrasound and infrared IR sensor, which one do you pick? How do you make the decision?
Is this set up for?
Yeah.
We just plug in this. So.
You have to do the tracking, say outdoors, like the weather could change, the weather could be muggy, then the light could change. Then which sensor would you pick for? Ultrasound, right?
Hey, what's up, guys? So we did the basic the track that it goes along the black tape, and then it senses the red, and then it keeps going. And we added the object correction sensor, so it'll stop at an object, and then it'll go around it, and then it'll find the track again and keep going. So, as you can see, that's what the objective was. And these were the chips we use.
So we had the tracking sensor, just like for the black line one. We wanted to make sure that it could still follow the black line, you know, make sure it stays on track. And we also had the...
We have the RGB color sensor, which is what would detect like the red or the color, so when it was able to stop. And then we connected it to these two, and then these two right here, and then we connected it to the front, and we put the tracking sensor and the color sensor and this little cardboard right here, so it could be perfectly in line. Otherwise, when you stick or something, sometimes it just get out of whack or motion. So this made it straighter.
For ours, we added a obstacle avoidance detector just to make sure that when we get close to that object, it knows to stop, do a turn, and get out of the way.
So for the code, we made sure that the obstacle avoidance is top priority. So if it detects an object, then, or if it doesn't detect an object, then it'll keep going to the track. But then once it does detect an object, then we make it stop and then go left.
So this is just a brief video we took like once we finally got it working. So this is just like right in the lab. As you can see, it'll stop and then it'll turn left and then find the track again. And here's another demo. It's on the, it'll stop at the red and then it'll find the object and then it'll turn left and it'll avoid it and then find the track again. And that concludes our presentation. You want to try it?
So this thing.
The batteries are dead. Yeah,
I think the batteries are dead.
yeah, we got new batteries.
Would it work?
That's something. Plug it straight into your Arduino board.
Oh,
Don't try
it's kind of working, yeah.
Oh yeah. Just don't try to take it off.
Yeah.
Nice. Find it. Find the line.
Maybe not that it has too much power.
Do you want her or not?
Is that good?
Alright, cool.
We're using a screw or that kind of screw.
So far, mostly have been used a different type of motor. For example, the motor for position control, right?
Sorry.
Yeah. Oh. I'm gonna sign in to show my colors. So. It doesn't let you sign in? Yeah, it's not letting me use my username. Let me ask Dr. Chow. Dr. Chow? Dr. Chow, can you sign into the Linux computer?
There's not one online where the ultrasonic swirl is find the right path.
It needs to be signed. It doesn't let anyone sign. Yeah.
Well, that was like a remnant.
I was created with first, and then I had to do
I haven't ordered it in
Is it signed in? And you can switch to computer 1. No, computer 1. Okay.
You know the same answer with the same
Oh.
and the same size of the food.
Oh, so if I wanted to split something, I just hit the computer.
Yeah. Do you wanna switch the computer?
Yeah, that's true. Just hit computer. There you go.
So we're doing the sweeper. Our first algorithm was go row by row, but it wasn't working because one of the wheels was going faster than the other one. So we switched it to the spiral. And now we're adding an obstacle to the track. So once it senses the obstacle, it's gonna go and spin around it.
Alright, so to begin we have a move function, which is pretty much both wheels going at one time. But as you can see in the beginning we have the speed minus 50, so that's what creates the spiral. It's going in a circle, and every so often through the loop it will move out a bit to slow down one of the wheels. And the loop is down here. And for what we were trying to do is add on a buzzer and an LED to the robot, and what that would have involved is us putting this tone function right here. So we initialize it by defining the pin and the tone, and that's all we should need to do was put it right there, and the LED as well. So just get back to
We'll bring that up later. The issues though is that when we started trying to add that to it, originally, as in this code it was 3, but we tried other pins. We have the speed for one of the motors as pin 3, so we switched it to 4, and then once we did that, we were changing all different pins, but for some reason we couldn't get the actual, or one of our motors stopped working once we actually started implementing that. And we couldn't figure out exactly why after even changing the code and setting different pins for the input on the alarm sensor. So pretty much it would go, the object what we wanted to do is when it detected a wall was to see the wall, make like a backing up sound, you know, like those, if you're in a warehouse it makes that beeping sound like, you know, the backup sound. And then also have like a LED light and then flash depending on what color you get, you know, it actually sees. So that's about it. But we couldn't get that to work, so. But other than that, it still runs and it will still detect an object and spin around it. Yeah.
I'm gonna go grab the obstacle. Ooh. Go, little robot, go! Yeah, it's also one of the limitations of our robot. We don't have many sensors, so it can really only sense stuff from the front, and if it doesn't detect it fast enough, then it just crashes. I think that one's gonna crash. Yeah. Ah! Sadness. Ah! probably one of the improvements we could do is like just up the distance of the sensor so that it doesn't just crash into the wall like that. Ah, come on, little robot. Dang robot. God, I wasn't doing this yesterday. Yeah.
No.
Mm-mm.
So it's on the side, you won't see it.
Yeah.
It's only right here in front. Alright. That's it.
Yep.
No, it's because you have it directly in front. So what it is that we don't so like if the wall's like right here and it's going at an angle, it won't see that. No, yeah, like when I try to do it on our like one was just it's all about it. It's like it's based on going forward, bouncing off. So it's
Hi class, how do you relate this topic to the robotic kinematics we discussed in the lecture? The servo motors you use are for what? Speed control, direction control, right? And what if it's a rough joint? You need a servo for the position control. Okay, and I believe it's included in the sensor kit. I also posted some code online so you can try it out just for learning purpose. Okay, and actually I expect someone may use that position control servo, you know, to move something like arm associated with the robot. But so far I haven't seen anyone included that position control servo. Does that make sense, class? So basically, for the position control, all we need to change is the input value. It's a discrete value, multi-digit.
Space.
9?
All over this.
Is group 9 here? So 5 will have that. So is someone from group 9 here?
Group 9?
Yeah. What? Where are they? Back there. Huh? How about group 10 then? Okay, so we'll start group 10 first.
No,
Should be able to. Well, as long as it's still connected to my, it's using my phone's hotspot. So yeah, yeah, it should be a good range.
Alright, hello, my name is Diego Quinones.
Brandon Finns, we are group 10, not group 9, as a reminder. We did a Wi-Fi robot, and this time it is working wonderfully. We connected to the hotspot on my phone. I have his phone connected to the web server that is set up with the Arduino. They're both connected to the hotspot on my phone using Wi-Fi, and he's able to control it.
So the way we control the robot is that I set up a web server using the Wi-Fi shield of the Arduino, and basically when you connect, we have in the code that when you connect to a Wi-Fi source, the serial monitor will print out the IP address that you're currently on, so that you use to control it. You use your Wi-Fi address, your IP address, and then the command. So right, left, forward. And that's how we control the direction we want the robot to go in. It's just our code. Yeah, it is. I don't think I can, but I can exit this. Alright, so we had to have, those are just the libraries for the Wi-Fi, and then we had to define the motors to get it to work like normal, like most people have to do. But you also had to, because we had an IR, what we added to our thing was an IR collision detector, so you had to define the pin that it was working on in the beginning, and then here's where we had to set up how to connect to a Wi-Fi source, so it had the name of the connection, the password. If you had like a certain key, you put it there. And that's part of setting up the web server. You had to define a port that it was connected to, and right there you set up the communication so that you can connect to the serial port. So we defined the pins there. Right here we have where we defined for the IR collision section. This is just telling us like if we're connected to something, it'll say it's not connected, and then this is what it outputs to serial monitor. That's telling us it's connecting to whatever we're connecting to, and then gives us the everything. We start the server. After it connects and it prints the status of the Wi-Fi, this is the part where we have that connect. That's the collision sensor. So if it reads a low signal, which means something is in front of it, it'll stop it.
Yes, the functionality we added is the infrared sensor. If it detects an object, it stops. So it will stop you from running into things and breaking it.
Here's where it detects for the commands to go forward, go left, go right. So it does in the serial right and the char read right here. then to control, we just we had our commands as a forward. That's our left, right, and stop functions. That's how you control the motors.
Some of the problems we had when building it is just like everyone else, we have battery issues. One of the wheels turns a little bit faster than the other one. One of the wires is a little loose, and we have trouble with the IR sensor in the beginning where it would detect things super far away, like probably this far away, and it would stop. And then other times where it would not detect it, so we had to just mess with the potentiometers on it and then try different ports and stuff. Eventually we got it working right. So that took a lot of tuning, and I think ready to demonstrate. That's connected.
So,
Go ahead. You want to use that?
Okay, switch it.
alright, so wanna grab like a sheet of paper and stop there, or are you just gonna stand in front of it? So that's it moving forward. Turn left.
Let me go the way. Alright. Send it forward.
Back up a little bit.
Yeah, it's working. It's just detecting me.
Yeah.
Yeah, the range is still. That's a little iffy on the range. There you go. That's working. Yep.
Back up a little bit.
It doesn't. It's like a really specific range for the IR sensor.
You have to be, if you're over the range, it won't detect it. But if you're
like under the range, it kind of detects it sometimes, and if you're over, it's like a really thin window to actually detect it like really lively. But
back up.
Turn left.
What?
Turn left.
I see.
Right. You wanna go outside and control it from like over there, like down the hall?
Oh, I need to see it.
Just do a couple of commands.
Watch on YouTube. So Wi-Fi has a greater range than
It should. As long as you connect to my phone.
Go further. I'm just opening up the branch for you. Go out further.
Yeah, that's moving.
It's turning right as well. What I'm seeing is turning right.
Yeah, that actually.
That's left. That's right. The wheels in the little balls in the back.
Oh, okay.
Seriously. How far down the hall are you?
He's right outside the door. Right here. Not cheating.
Just go like all the way down.
Let's see how far you can go. How far you can go away.
The C one of the wheels is slightly faster than the other wheels, so it doesn't go perfectly forward. Yeah, it's working. Yeah, he's down by the bathroom. Still controlling it. Alright. So with Wi-Fi, you can control it from pretty much anywhere that you're still in range of the hotspot, as long as both devices are still in range.
Quick question, I'm a little lost for the demo. What is expected?
So we have the collision detector in front, so if it's traveling forward, if there's anything in front of it, it'll automatically stop.
Okay.
So you can't, if you're controlling it out of line of sight or something, you can't crash on an accident. Since you have
So basically like
the other range of the Wi-Fi.
Yeah, it's like how the smart cards work, where there's something in front of it, it'll stop the collision detection.
Okay.
Like an ABS system on your car.
Heck yeah.
Alright, thank you.
That's it, thanks.
Since they are the only group with Wi-Fi control, right?
Yes.
Most other things use
I don't want to see neither hair nor hide of this freaking house. Or my hair. Trying to do I am.
What's the keyboard on this thing? How do we? Alright, so you're fine with doing these two sets?
I will show you.
Alright, how you guys doing? So, my name is Matt, this is Alejandra, and we did the line tracker with an ultrasonic sensor. She's going to explain to you how we set everything up.
So we use 4 sensors, and the first 2 sensors, they're the line sensors, and this is the depth sensor and the frame sensor. Then for color sensor, we put it on the right side, and this is this one. Then for ultrasonic sensor, we use it in the front.
So, first I'm going to talk to you guys about the movement functions that we have on it. These are just basic, like I wanted to talk to you about what we actually changed, because all the other code you can just look at the book, and it's just right there for you. So what we had to do with our servo motors is motor A was actually set up backwards, so we had to do counterclockwise and change that. And then besides that, it's just forward, bear right, bear left, and then stop. And then for the main loop, obviously you have to initialize everything, so I didn't really want to talk about that too much. But what I did want to talk to you about is what's really important is having like all these different output variables for you, so you can just comment them out, and then if you're ever having a problem with your project, you can just uncomment that and then just play it, so it'll just constantly read to you instead of you like freaking out, uploading a new program and then reading the values off the new program and then going back and changing it. Just remember you could just comment stuff out and make it easy on yourself. And then for the main loop underneath that, so what I did, we prioritized ultrasonic sensors, so whenever it is reading something, then it reacts. It's not just the line sensors in the front saying, oh, I'm reading black, and then do something with that. Instead, it's just ultrasonic sensor once it gets to a certain distance, which I think it was like 10 centimeters. If it's over 10 centimeters, it does its normal line tracking, and then it does the normal red tape like stop function. And then if it's under 10 centimeters, then it'll bear right and delay. And I'll talk to you about why I just made it bear right and delay. I have my own track at home, so I'm not actually going to demo it in class. I'm just going to show you a video. And this is my track. So I just wanted to implement how the ultrasonic works, and like I wanted to understand a little bit how it's detecting, if there's any variances with light or anything like that. Obviously there wasn't when I got up to it. So you could just, I wanted to explain the code before because you could just look at it and go, oh, all this guy did was didn't even use the ultrasonic sensor. He just made the line tracker go up to this. Because my RGB is on the right, you can just tell it to turn right when it gets there. But I showed you the code, so it's not actually just doing that. And then for the demo, hope this plays. No. It plays on my computer. I uploaded it to my drive. I wonder if I could pull it up on my drive.
Shareable.
Make it shareable?
Yeah, there's like a permission setting in Google Drive and be able to play it on other things.
Well, I wonder if, can I just play it from right here? No. Okay.
You have to copy the video, right? Do you have the video on the flash drive?
Yeah, you download the Google Drive.
Let's see.
Can make someone that's not doing that.
I know you told me that.
You don't have a demo video of like you taking the obstacle away and just keep on going straight, so it proves that you're using ultrasonics?
No, I don't. I just showed you the code, so I figured you guys would be okay with that. But I could for the upload on Friday if you want me to. So, no, what the heck? You can see it's right there.
Try downloading it.
Okay. This is all my ploy to make you think I'd made it work. Well, dang. This is kind of unfortunate. I can play it on my phone if you guys want to come up close and look at it.
I can. Yeah, put your phone in front of his phone.
Yeah. Oh yeah, that's right. You can do that. Alright. Let's see if this works first.
Go back there. Go back. There you go.
Wait. Will it work? Hasn't loaded anything yet. I'll just show it to you on my phone.
Alright, here.
And then after this, I'll talk to you guys about the future improvements for it. So, actually. So you can see it. Okay. You can see it go up to it. It turns right here because I actually had like a couple of liquor bottles in front of it. But so it just came up to it, to the sensor or to the object, turned right because it's bearing right, and then just follows the new line and then stopped at the red light as you saw, and then it continued after that. But just the ultrasonic sensor at the very end detects something. Just, oh shoot, and then it stops and then it goes for the normal delay. So we were able to implement the ultrasonic sensor correctly, but future improvements for it, because I couldn't I didn't want to just put an object on my track and then just make it turn left real quick, turn right real quick after a couple of delays, because that's not a a global solution to all objects in front of it. That's just for that size of the object, you know? So personally, if I had the necessity to make this work like really well, I'd go out and buy a couple of ultrasonic sensors and put it on all, like 3 on both sides of the actual robot. And then as it's passing an object, I'd make it detect it, like constantly tell it, and then once it gets to the very end, then it'd turn right. So it'd have like a, I'm coming up to it, you can tell it to turn left or right, and then the right sensor, like if you tell it to turn left, the right sensor is saying I'm going by it, the middle sensor is saying I'm going by it, the last sensor says, oh, I'm all the way by it now, I can turn right and go back to the track. And then that'd be like a global solution for any object that you want. Another one would be, I think if you guys all did the line sensors, we saw with a couple other groups, we have trouble with the threshold value for the actual track. If we wanted to, you could take the button inside the actual package that we got from all the different sensors. You can take a button and put your line sensor up to the actual track and then press that button and then code it to where it'll read the new threshold, and then it uses that threshold to go on the track, so you don't have to constantly always adjust your thresholds all the time. And then another nice thing would be to add another RGB sensor, so it's not just like mine's only on the right, so I can only go on tracks where it's detecting it on the right. Left and right would be nice. And difficulties that we had, battery power. I tried to find the happy point. I think it was like 120 when I was like for the actual code for my batteries, so I could do like 20 runs without it actually having a performance issue. Dirty track. I don't know if you saw on the actual on the video, but I have like a couple. I do a lot of like outdoor stuff, so I'll come home, I'm dirty. I'll have stuff all over my table, and it'll be dirty. I'll try and run my project, and it'll just mess it up pretty bad. And then keeping sensors in the proper spots. So like the book suggested that you use a what was it, a paper clip for all this stuff. That's what I ended up doing for like the RGB sensor, and then I used a paper clip on the top of these and just taped it down. But it still varies a lot, and you can have a lot of different thresholds. So it'd kind of be nice to maybe make my own system to where it wasn't dependent on paper clips. It could like just have them in a set position, then you have less problems with coding. And that's our project.
Yeah, just change it to like whatever you want to do it, like.
Explain like what's wrong and like how far have you guys got
whole package for the lab throughout the quarter for this course, so you need to turn the back before the final. Otherwise, you will get incomplete or even F if you do not turn in your equipment on time. Or send more detailed instructions.
What's that for? It's for
Hello everyone, my name is Trinda, and we did the line tracking robot. We used the line tracking sensor, the tracking sensor, and also the red, green, and blue sensor. We also implemented the but as soon as we put it on, it wasn't working. But on the track, it follows the line, and whenever it bears right and it hits the black, the buzzer goes off and tells the Arduino to go back. So it's like in today's, you know how all the cars are coming with the lane assist? That's basically what we did. Is when it goes like that, it goes on, the buzzer sounds off, and then after the buzzer turns off, it goes back and keeps going straight. And it goes again, line goes off, the buzzer goes off, and then the line, it keeps going straight. And right now it's not working. Just it's going in place like this.
So yesterday we tried to implement a buzzer on there. The active one doesn't work, so we switched it up to a negative. It did ring. It was pretty loud. Also, it was working yesterday. Today it doesn't want to work. And it was following one of that black tape, but so far one of the wheels just keeps running, so it won't follow it right now. But that's how far we got right now.
I hope you had fun on this project. Also think about the potential extension of the project. Also, now I believe everyone now has a better understanding about the design constraints, right? Given any project, you have to consider the constraints when you come up with the project specifications, the design and implementation. Through this project, most important thing you can learn is, with more sensors, more options of sensors, with higher accuracy and precision, you have more potential to extend the functions of the robot. Again, for motors, you only use one type of servo motors, which is for the speed control, but you can introduce different types of motor to simulate or to control the joint movement, like rotation angle, also translation distance. Okay, we still have 30 minutes. I think 30 minutes. Any questions for the final review? Okay.